I'm going to be sharing a number of sort of ideas to inspire you along the way and give you a flair of what we are doing and how I think some of that might be of relevance to you. If you want to learn more about the actual research we do, this is taken from my website. So you can click on these sort of highlights. We work with insects in agricultural systems. We work with them as bioconverters, which is something I will talk about here in a little bit. We work a lot with pesticides in different ways, and then we work with remote sensing, use of drones and optical sensing equipment in different on different spatial scales and in different settings. But it's all driven by solutions. It's all driven by a deep desire and commitment to serve the community we are part of. We are deeply committed to helping the generations that come after us to have a more sustainable future, to have food that is safer, cleaner, and produced based on less resources. So we are very much looking at the end goal and trying to find out what technologies and what research needs to come forward, be done so that we can get to those end results. Um, I also want, since I'm still talking about my website, you can go into this header about education. If some of you are aspiring to go abroad, I have, because I'm a foreigner, I am from Denmark and have lived in many places and have studied in many places, had students from all over the world. So I know what it's like myself to be a foreigner. I have had lots of international students. So I have specific suggestions and comments and ideas and thoughts that could be of relevance to you. And then also, and this is something I will bring up later in my talk here. I'm very dedicated to scientific writing, how we can use that as a tool to communicate to the world, how we can use science as the foundation for discussions and decisions that need to be made by society to help politicians and others, administrators, make the right decisions and put the laws forward that really bring us the conditions, the rules we all need in order to be successful and produce food in a profitable and sustainable way. So I'm very keen, very, very dedicated to scientific writing, and I have a video about that. I have some notes about scientific writing, and then a whole bunch of sort of suggestions to those of you who are looking into grad school one way or the other. So sort of stay in the academic career beyond a bachelor. So feel free to utilize these completely free resources and reach out to me if some of this seems useful to you. That would be very, very interesting for me to learn about. And my hopes with this seminar are very sort of very straightforward, but also very, very sort of very important. And I really think that it is important for you to know how important you are. That you, the next generation, you, the young people of the world, you that have made it to the universities, you are the elite. You are the decision makers that the rest of the world will be looking to. And you will be taking up positions in leadership, and your way of making decisions will influence the world. And that is both gratifying, but it's also a huge opportunity and a big responsibility. And I want to talk about how you give you some ideas towards the end. I will talk about how I think you can use the fact that you are at a university and getting a higher degree, how you can use that as a vehicle, as a catapult to get you into not only making decisions and making money, but also really help progress this world in the right direction so we can be more sustainable in our societies, in the way we produce food, how we use resources, and overall have a more healthy planet for all of us. So and I think that is probably my biggest responsibility as an instructor, as a teacher, as a professor. I think the biggest responsibility I have is to inspire young people. So I take that very seriously, and I I'm going to do that today, hopefully, so you can walk away with some ideas and maybe some energy you didn't have had before, and hopefully some thoughts that you can then think of. Where are you now, and how can you use the position, the career, the particular course, the particular major you have? How can you use that to really sort of excel and also have a meaningful career? I want to make very clear links between your career aspirations and the community you are part of. And when I say the local community, I actually mean your school. I mean the city you're in. I mean the county or the area you're in. That there are many, many ways, and I think we need to look at that more and more in the near future. We need to really, really look at how we can use our schools as living laboratories, how we can experiment as part of our studying, that studying is not just about memorizing, reading books and memorizing them and knowing how to do calculations and say fancy names in Latin. There's much more to it, that schools need to be experimenting. And I mean, I'm at UC Davis, which is supposedly a very famous agricultural school. Well, I ask the simple questions. Why are we not growing food on every single building at UC Davis? What are we doing with our water? What are we doing with our waste management? Why are we not driving self-driving vehicles on campus? Why are we not every aspect of what the school does? If we are as smart as we claim we are, why are we not doing those things on a daily basis? Why are we not using the university itself as a playground, as a petri dish to experiment? I think every school, every university needs to do that in order to stay relevant in the future. That there's this big pressure for online teaching, but what online teaching can't do is put these two hands in action. What can you the hands-on experience you can get by doing something on campus? How can we make the campuses more active? Big question for administrators. And that brings me to my final point, that I hope that there are some university administrators also, and professors and instructors that are looking at this and maybe thinking, wow, maybe Christian's ideas, some of them we could actually implement. So that's where I'm going with this, a big agenda. But it's really about focusing, getting inspired, getting fired up about who we are and where we can be and how many opportunities there are right in front of us, right underneath our nose here. Because we have lots of challenges, right? It's very, very easy. You open the news, you look at it online or radio or whatnot, and we have pollution, we have air pollution, we have flooding, we have fires, we have poor quality of water, we have climate change. It is extremely easy for all of us to feel perplexed, paralyzed, disempowered by all these challenges. It is very easy for us to lose hope and feel that, what can I actually do? And I think as a teacher, as a professor, as part of inspiring students, it is within this context that it is my absolute duty to show students, show young people that while we are handing you this horrible deck of cards, these very, very challenging circumstances, there's a lot of opportunities in this. That there are lots of ways that maybe we can use these paralyzing or very, very big challenges in a positive way and do some very, very great things. Because I recognize that young students, young people I have daughters myself, and I know that they are very concerned about the future. And so they feel uncertainty. They may feel paralysis or anxiety. Well, what we need is to replace this, right? We need to convert it. And that's what universities and other schools, educational systems around the world, we need to empower you young people, show you how important you are, and give you the opportunities, the tools, and the contacts and whatnot, so you can take advantage of this and help us get in the right direction. And really not focus so much on all the disasters, but focus on the possibilities there are and turn these challenges into opportunities. So I look at it kind of like a scale, right? So we have this relationship between these two, and what we're really hoping is to give this more weight so that you are more focused on these things, and much less on these challenges, and really as part of this become more sustainable, and help us be more successful, and also use this set of challenges as a way to be successful in your career, both monetarily, become billionaire. I think that's great. I think that's really, really important. Think big, but also have impact and really push the agenda so that we have higher level of sustainability and a better planet. So um, so sort of to the administrators here, I really think that what we need to look at, and you students, you can also drive this, you can push this in the right direction. It's not just the top people at the top of the food chain that need to do this. You can really help us here, because we have this sense of urgency, we have all these challenges, we need to implement them into the way we teach, into the way we do research, so that we can have very solution oriented education, very, very focused on specific targets. So we need to learn how we can take the tools that we are learning in school and turn them into real solutions. And I mentioned the living laboratories. I really think schools need to have a much wider program. They need to do much, much more, not just write papers about what the world should look like, but actually demonstrate to the world what the world should look like. A school should be an experience. You should be walking into, if you visit UC Davis or if you visit another university, you should be walking into an environment where any visitor would say, wow, they're not only talking the talk, they are also walking the walk. They are also doing things that are cutting edge. They're exposing the students to these real challenges, and they're really trying to, on an organizational level, do what they're actually in their research search claiming is very important. I think that is extremely important. And I think as part of this, we also have to sort of abandon this one-way knowledge transfer where there's a professor sitting on one side and then we have a whole bunch of students out there just receiving and expecting that we know it all and that we have the answers to everything, because of course we don't. And really, education is not about us as the professors, as the instructors. It's about you. You are the important people. The students are the important. It is what you want to do, not what we wanted to do 20 or 30 or 40 years ago. That's not, nobody cares about that. What is important is, how do you think the world should look like, and how can we together develop living laboratories and come up with research, cool science that can really solve the future's problems. And in that part, I want to go back to my slide about literature review and scientific writing, because I think there can be a lot of project-oriented research and teaching that can be done on schools, and I really hope that schools around the world will. There's already some, and maybe on your school, when we get to the Q&A session, maybe you can tell me a little bit about what you're doing. But then we need much, much more of this, because this is also the experience that companies and others will be looking for when they hire you. They want to know, have you actually done this? I mean, okay, so you read a book about it, or you passed a test, you did very well in a class about it, but can you actually do this, right? That's what we want. We want people who can solve problems. And we've really, and this is where I'm sort of leaning or getting towards, is this what I call disruptive ideas, or this situation of what if. This idea that we allow ourselves, we dare to say, what if we could do this? And how we can promote teaching where it's not about one-way transfer, where we give you all the answers. No, we should plant seeds in your head so that you come to us and say, can we do this? What would it take to do this? That is sort of, as an educator, is the golden moment. This is what we are looking for, is that students take what we present them with, get inspired, process it, and then turn it into something that they can really do themselves and take very far, and turn into something that we had never thought of, and really attack a problem, come up with a solution that could really make disruptive difference in the world. Disruptive in a positive way, meaning that it fundamentally changes a given paradigm, a way we look at things. And I'm going to give you some examples of that here in a little bit. So we'll get to that. But let's just stay with this student competition, this sort of the environment that a school is not just about giving lectures and grading students. There should be much more to this experience of going to a university. What if we had companies involved? What are the companies in your neighborhood, in your city, in your county? Why are they not sponsoring different competitions and scholarships and prizes? Why are they not putting money into schools and providing ideas to what they need answers to, so that they can recruit you and you can go out and get a real job? Why are we not using the resources, the financial resources, but also the priorities? Why are we not using that more effectively in our teaching and integrating that into the experimentation, the research, the teaching that we are doing? I think that is extremely important and is not being used enough. This is going to be very important if we want to keep the universities relevant in the future. Clubs. So at UC Davis, they have a robotics club. So students after class, it's typically in engineering, do stuff. But there could be many clubs, many clubs with different purposes that could do all sorts of very fascinating things. Robotics is sort of a very broad area, but there could be clubs about solving the water, using water more efficiently on campus, or the food from the canteen, or where you for the dining hall or whatnot. Where is that going? Growing food on the roofs or on the walls of all the buildings. Transportation on campus. How can we make that more effective? These are real problems that could be researched at a very academic, very theoretical level, be turned into projects that could be funded by companies, and they could afterwards be implemented in bigger cities or communities elsewhere. And that would give you some of the best experience you could possibly think of, the best preparation for you to then go out and get a job somewhere. So that is really something we need. And why? So this is something I'm doing quite a bit of, and something that when I really have a student that I think is writing well, is I'm pushing them to is, so you have to give a report in a class of some sort. Well, why not turn it into an opinion paper? Why not try to get it published somewhere? Why not be serious? Why not sort of embrace that importantness, that the fact that you are important? Why not take it all the way and really try to make a difference and write it in a way so it can get published? So that's why I'm giving you a lot of sort of details on how to write scientific papers and whatnot, because I think you can really use this as a. And I talk about mini reviews, which is a type of articles that I've actually published with undergraduate students in the past. So it is possible. I know that. Kind of interesting that also sort of regular outputs from classes can actually be turned into outputs that can then be used in your career for scholarships and other, so you can really demonstrate your talents in terms of scientific writing. And at your school, as I also already mentioned with these different examples, you can look at your school as an opportunity, at your university, your local community, as an opportunity. You could, together as groups of students, potentially from multiple disciplines, go together and propose something to the local government, or in other ways really try to engage and make true connections between what you're learning in class and trying to implement it. If you're willing to sort of, if you dare to do the what if we took that idea we discussed in class and actually put it in action? Think about that. Why not, is my answer to this. Why are we not doing this all the time? It shouldn't be the exception to the rule. That should be part of training, because that's where really online training comes short. We cannot. That's not something you can do online. And there are lots of resources out there. I'm just where you can get inspired, where you can learn about what other students are doing. I happen to be quite involved with this organization called Futurum Careers in England. They publish a lot of studies that are meant, so the stories here are meant to inspire teachers to do projects with their students. And some of there are also students publishing in this at this website. But this is really where, if you can, there's a search engine here. You can go in, you can learn about different topics, you can see what other students are doing elsewhere in the world. There are activities that can be implemented into courses. So these are also ideas if you are thinking of grad school, if you are interested in physics or in genetics or in conservation or robotics or something. You could maybe get some ideas and see how this is done elsewhere. And this is completely free. So you can go in here and you can search these articles, or you can, and I've published here a couple of times, one about a smartphone app I developed with two computer science students. And so you can read about that. And I think as I'm saying, I really think we need to rethink education and make it much more experimental, much more driven towards solution. And this is my youngest daughter, Molly. She's now 12, and this was last year. This is our front yard. Actually, you can see there's a lot of onion going here and some cabbage. And we did a project during COVID because she wasn't in school. So she did a project about growing cabbage, and she learned about vitamin K, and she used Google Earth to make some estimates of how much if you want. So first she needed to calculate how much vitamin K she as a 12-year-old needs. And we then found out how many students there are in her school. So how much vitamin K would you need for the daily requirements of her entire school? And then we found out how much vitamin K there was in cabbage, and then how much cabbage would you actually need to grow. And then we did a Google map, and we took the playground at the school and converted and found out how much of it would have to be converted into cabbage field to grow cabbage. And then she actually made some muffins with cabbage, so she learned how to actually eat it and all that. My point here is there's so much to be learned about nutrition. This is not just practical work. There's a lot of theory. There's a lot of genetics and physiology and chemistry and math that can be learned by these sort of real world applications. And that's why I'm launching this School of Food, which is something that schools can register for. And so I'm just making a pitch for that. If you know people that are working at schools, please go to this website and look for School of Food. And we are sort of in the process of developing that. And then what we want is for students around all over the world. We already have schools on 5 continents signed up here. We want them to share videos of how they use food to learn different things in school. So really examples of how we can promote this living laboratories idea. So the last part of my talk is about this what if, because I think that is the key goal to successful education, is if we as instructors are able to inspire you to have the courage to sit back, talk with your friends, your family, and then ultimately come to us as your mentors and say, what if? What if we could do this? How can we solve a particular problem? Because that is the key to education. It's not how much you learned, it's how you used what you learned and turned it into something meaningful to yourself and to the people around you and to the world as a whole. So I'm going to give you some examples of what if here, which we happen to work on in my lab. So we'll get to 2 of my PhD projects right now that are going on, and we're going to talk about them. And the first one has to do with waste, or even better, what if we could abolish the concept of waste? Think about that for a second, because what is waste? Well, If you look it up, you will actually see that waste means that something is left behind. Something no longer has a value. It has no use, right? Well, I will argue that everything that we throw away is a missed opportunity of making money. And it's basically based on ignorance. We are not aware of what we are throwing away. And it is our duty, it is our responsibility. If we are as clever as we claim we are, we should be able to use whatever other people are throwing away in a smart way. And I will even go as far as to say that the opposite of waste is sustainability. These two are incompatible with one another. You cannot have sustainability and waste at the same time. And I will argue that the key goal with sustainable development is to get rid of waste. And I'll give you some examples of how we can do that. Because I work with insects, we're going to talk about insects, of course. And we're going to talk about how we can use insects as small machines, as small living organisms that we can harvest and then do things with. Many, many beautiful, very nutritious, very valuable things we can do with insect bodies. And we can feed them something that we were otherwise throwing away. And what we were throwing away was producing greenhouse gases. It was filling up landfills. It would be causing all sorts of those problems that I showed in the beginning. We could, instead of throwing all that waste away, we could use it and turn it into insect biomass. And you can approach this as an entomologist, as an engineer, as an economist, as a politician, as an evolutionary biologist, as a modeler. I don't care who you are. This is relevant to you, ladies and gentlemen. There are currently, and several species are being used, and I could be talking the whole hour just about this. But there are particularly one insect, the black soldier fly, which is something that is being used a lot around the world. There are many, not many, but there are, especially in Europe, but also in South Africa and other places, there are cities that are now having insects convert their organic waste in multiple ways. And they are producing billions of flies each day and converting tons and tons of waste into these maggots, into these insect bodies. And what you can do with them is rather extraordinary. And just for comparison, so if we look at, for instance, protein, how much it takes to make a gram of protein based on beef, well, it's like 12 times less if you use insects. If you look at how much water it takes to produce 1 gram of protein, if it's through traditional livestock, you would have to use much more water than you have to use if you're using insects. So protein, lipids, for different proteins can be used in all sorts of ways, and they can be, so we can use the insect instead of having chemical engineers engineer complex sort of fractionation and digestive systems. We can simply feed these waste streams to insects and have them do the job. And then we harvest the insects. And then what do we do with them? Well, we can produce jet fuel. We can produce protein that can be used to feed livestock, or we can put it even into human food. We have leftover material, what we call frass, which is basically all the leftover material that can be used as a soil amendment to grow high-end vegetables or other crops with. And all based on things that we thought was waste, things that we were going to throw away. People were willing to give us money to take that. Now, what is going to happen in the future, hopefully, if things go well, is you can sell your banana peel somewhere. We can sell our waste somewhere because it's going to be so valuable because of all the things that can be produced from this. So there is no reason why we think of waste as a big problem. We should think of waste as a huge opportunity. But we need engineers, we need biologists, we need chemists, because, and we need entomologists and others, so we can look at. We are using black soldier flies, we're using mealworms, we're using a couple of other species, but it's less than 10 insects right now that are being used. But think about the millions and millions of insects out there. So if we explored the biodiversity of insects and took advantage of their fascinating ability to adapt to different living conditions, we may be able to match a particular waste stream from a particular production system with a particular insect, and they could go together and become this unique opportunity to convert something that it would otherwise cause all sorts of problems for us as a society. We need engineers to come in and develop these so we can make them big when we have big production facilities, but we also need them behind. Maybe this could be on the backside of a coffee shop or a bakery or a brewery or some other places, or maybe behind a school. Maybe a school, every little school should have its own, and then these insects could be harvested and used for something. We could even go the obvious route, which is also genetically engineer these insects so that we manipulate their gut biome and their genetics themselves, so that they can convert something like that it would be like plastic or some other something we can't get rid of. We could approach this as insects being these machines we can use to solve a problem for us. So I really think, I'm going to be very bold here. I'm going to say that I think insects are going to be the livestock of the 21st century. We may already now, some of us, be eating a little bit of insect in our daily diet, but I think we will see this explode very, very soon, because the economics of growing insects are just, they outcompete everything. So it's not a matter of if it's going to happen, it's how it's going to happen. And the question is, are you up for it? Are you going to join this ride? Are you going to join this incredible movement of coming up with insects as this new solution to our waste problems, and turn them into lots of kinds of money, lots of ways that we can have new careers, new ways of making agricultural productions? So I think insects as breeding, insects as developing systems from an engineering standpoint is going to be something you will see you can get degrees in the very near future. There are already scientific journals that are specifically targeting this area, and it's growing. So it's a question of, what do you think? What if? Are you going to be joining us on this fantastic ride that it's going to be? And Trevor, my PhD student, is working on that. He's also founding a company. So he's actually, as he finishes his PhD, he's going to go in and actually commercialize this and develop ways to sell these insects as feed for the poultry industry. So that's something we are making direct connections between what he's doing during his PhD and what he's going to be doing in his future with a startup company. And then we're going to jump to a completely different what if, which is more engineering based and a more ecological based, but it's another what if. Think of all the pests that are out there in agricultural systems, and many of them migrate. Many of them come into the fields because the fields are typically at some point during the growing season left bare. There's nothing going on there. So they have to come in. What if we could predict when and where they come? What if we had a better knowledge, better understanding of when they're going to arrive and how severe this year's pest infestation is going to be? That will inform us a lot about how many pesticides, whether we need to use pesticide at all, whether we could use biological control, and all these things. So what another of my students is working on, and that's Hyosok Lee, and he's working with a very, very interesting insect. So this is California over here, And there's a lot of tomatoes being grown in this green area here in this valley. But over in these foothills, over in these hills over here, that is where this little insect called the beet leafhopper overwinters in the green vegetation during the winter, because here in California it rains during the winter. So the foothills get very lush and green, and then as they dry out, they migrate from the foothills um, into the agricultural systems in the valley. So what Hyosok has been doing for the last couple of years is he has done a very, very interesting and very unique combination of studies. So he has been out in these foothills, and he has been setting up these traps to over during the season find out when are they flying, when are they migrating. He's also found out what are the species of weeds that they are living on in the foothills, and he has taken them back and found ways to grow them, and then put them in a growth chamber and find out how many eggs they lay, how long they live, so he can do what's called life table studies. So now he can do mathematical models of how they develop as a function of temperature and time, and as a function of which species they are. And once he has done all that sort of experimental work in the lab, he can then use imaging, satellite image analysis, to then look at the greenness of vegetation and study how that changes over time, and ultimately through Google Earth come up with an algorithm that can sort of convert greenness of the vegetation into risk of migration of these beet leafhoppers. And then we can, so what we can now, what we are now with this extraordinary project, what Hyosok is enabling us to come up with, is a way where we can actually alert people. We will be able to, if they sign up and they give us their where their fields are, we can alert them and we can let them know, hey, just so you know, the leafhoppers are coming. Okay, this year it's going to be a bad year, so you may want to stock up on insecticides, or you know what, this year it's not going to be a problem. And we actually forecasting that this year, that because it's been a very dry year, very dry winter, we actually expect that the vegetation this year has been so dry in the foothills that we can then provide growers with information about, we don't think there's going to be much of leafhopper activity this year, which gives them a lot of relief. So we, based on combining these very, very different types of research, and some of them being very, experimental and done in green, and some in greenhouses, some in the lab based on modeling, we can develop these spatial tools that can be turned into smartphone application, into decision support tools. And that will ultimately minimize the risk of them spraying out of ignorance, because maybe they are afraid, so they don't know what to expect. And that's what happens a lot in agriculture, is that growers will spray out of fear. They don't know whether they have a problem or not, but they will spray anyway. Well, that's why we need to provide them with the tools to find out whether they have a problem or not. That is our duty as the people who are in a position to do research. We cannot expect farmers not to use pesticides and do all sorts of crazy things unless we give them the knowledge that allows them to take smarter decisions. So that's why it's our duty to come up with these decision support tools. And I think we can also, so we can minimize the risk of overuse, and we can also help them find out if this is looking bad. We can also help them, well, you better get ready, because this is going to be a bad year. So we can also avoid $1 million crop losses, and that is certainly something we are all interested in. None of us are in the business of just promoting solutions of not using insecticides. We think that it's important to use them, but use them in the right way, and only when and where they are needed. So this is what Hyosok has been doing and is working on, and he's really it's a very, very interesting project that combines some very sort of advanced internet-based tools and modeling with basic biology. So quite a fascinating way of dreaming out loud and coming up with a very creative solution. The last thing, the last what if is what was also mentioned sort of in the beginning here, is some of the work that we do with drones. We are very interested in using drones and other robotic technologies as a way to automate decision making and collection of data. And some of you may be familiar with spider mites, one of the biggest pests around the world, uh, showing immense levels of resistance to a lot of miticides, because it's associated with drought and becoming a problem in crops that are under drought. With climate change and lack of irrigation water, it's becoming an even bigger problem in the future. So spider mites is definitely here to stay. They will be with us for a long time, and we need to find smart ways to control them. So so this is when we look at how strawberries are being grown here in California. So you can see we're talking about acres and acres and acres, all looking very, very uniform. The interesting thing is that even though this looks very, very uniform, it's actually less uniform to a spider mite, and there are pockets within this otherwise sort of uniform ocean of crop. There are areas where irrigation is not working, where the fertilization was suboptimal. So we are seeing that it's not quite as uniform. We as humans may think this is uniform, but spider mites and other pests don't see it that way. So what? But when you have a scale like this, and we can then come to growers and we can say, oh, Mr. Grower or Mrs. Grower, you shouldn't be spraying miticides. You should be using biological control agents. Well, here's the problem. Okay, this is the way that they are releasing predatory mites to control the spider mites. I'm asking this simple question: how am I going to go around and squirt this if this is my area? This will take me weeks, right? There's no way I can do this. So I cannot expect growers to adopt biological control. I cannot, even though this is fascinating technology using some predatory mites that can eat the bad guys, even though that technology exists, it is not suited for something as big and industrial sized as this. So there's a gap here. We need to solve that. We need to lower that, or sort of mitigate that gap by coming up with a solution that can allow us to do this on a much larger scale. And that's where the drones come in, right? So if you have outbreaks of spider mites, which is what this is sort of depicting, imagine you could have a set of drones that are flying around over this enormous area and gather information about the reflectance of the crop. And this is something we're doing as well, which I don't have time to talk about. But imagine we're doing that, and then that drone that senses and assesses the level of stress in the crop communicates with another drone, and then this is the cavalry. These are the good guys. They're then coming in, and this drone has sort of mapped out where the hot spots are, where we need to release the natural enemies. That is where it's then being guided to go and do the work. Then if we can make this happen, we can then growers will have the solution, will be able to, on a commercial scale, do what we all want them to do, which is use less miticides. And they want to do it too. It's not like the growers want to use miticides. They just have no alternative because we haven't developed the technology. So we need to do the research. We need to develop the tools that they need in order to perform sustainable food production. So that's in our court. We cannot expect them to do anything before that. So we are working. So I'm in the entomology department, right? And I'm actually working very closely with the Department of Mechanical Aerospace Engineering, not a sort of a team you typically see working together, entomologists and mechanical aerospace engineers. But maybe in NASA or someplace else, but not at a university. But we are, and over the last couple of years, we have developed different devices to be mounted underneath a drone. This is the most recent one. This was flown for the first time last week, actually. So there's a lot of innovation that goes into this, and I'll just talk briefly about what needs to be developed in order for this to be successful. Because there's a lot of fascinating research, and this is again coming back to this living laboratory and doing sort of getting your hands dirty and really sort of think in practical terms. How can we do this? So what we do, and what you can't see here is that underneath the drone, so the what was being let me just go back here quickly. So here, what you can see here is happening is that what is being sprinkled out is a combination of predatory mites and what's called vermiculite, which is basically a carrier that keeps the mites alive and helps sort of add volume when you are releasing them out. So what we are doing here is we are putting vermiculite into our container, and then we are spreading that out. And this is now a very large container. We're using a fairly large drone and an octocopter that can fly for quite a while with this type of payload. And you can see here, so here it's releasing, this is an older version of we call this the bug butt, not a robot, but the bug butt, because it's releasing, this is the name that engineers come up, because to them all insects are bugs, right? We entomologists, of course, we know it's an insect. A mite is not a bug, but we'll give them that. That's okay. So you can see vermiculite coming out here. And I'm going to show you here in a little bit a movie of what we're trying to do, because really what is important here is that even though there's a lot of downdraft from these rotors, and you can see that it's precision guided and there's a lot of control that is going on, even though there's a lot of downdraft from the drone and that pushes the vermiculite and the predatory mites down, strawberries, which is what you saw, is grown typically along coastal areas in California, and there's a lot of wind, and vermiculite is very light. So even though you are releasing and it's coming down as a nice stream, sort of vertical stream here, once it gets a little bit further down, it's at the mercy of the wind. So again, that's not me, because this is over in the engineering department. They are doing very advanced modeling of the fluid mechanics of vermiculite in the air in the column of air underneath a flying drone, right? So they're finding out if the wind is coming from a particular direction at a certain speed, and the drone is flying at a certain altitude in a certain direction at a different speed, where will this vermiculite actually end up? So we came up with this very, very sophisticated system here where we have sticky boards, and you can see this takes a lot of people. So this is where we can get a lot of students involved in hands-on research. We put up these sticky boards, and then along sort of perpendicular to the flight path of the drone. And then you will see here the drone is coming flying here, and he's signaling. We have a weather station measuring constantly the wind. You will see that it will start squirting. So there you can see it's coming down nicely. So we can sort of fly here, and then under different wind conditions, when it's different and different directions, different altitude and whatnot, we could then collect data on how vermiculite is being spread by the drone as it flies. And then we could then take these boards, and then we could take the tape or the transparent sticky surface off, and we could do image processing of that and find out exactly how much vermiculite that landed on these particular boards. We knew the position of the board, so you can see here the vermiculite as it's being deposited. And then April, who published her research on this is the sort of the trajectory. So when there's no wind, you could see that the vermiculite was sort of falling very nicely along the flight path of the drone. but if we have a slight side wind, we could see that it was being pushed to the side. So we can now model that. Another project is now developing uh, in another model. They're finding out how the drone can be actually assessing and the wind speed as it's flying, and then that can be integrated into the control system of the drone so that it can offset its position as it's flying, because it knows where it's supposed to drop the vermiculite. But if the wind is coming from a certain side, it needs to offset itself so much in order for that to happen. So this is very, very cool entomology. This is 21st century what if technology. This is as sophisticated as it gets. But this is exactly the kind of stuff, the kind of research, the kind of ideas we need to have. This is the kind of stuff that you need to be sort of engaging in. These are the kinds of ideas that we as a society need you to come up with, so that we can enhance the feasibility of biological control overall. We are now also, because so in another huge crop in California is almonds. Well, almond trees are huge, so you can't squirt, uh, and they have spider mites too, but you can't squirt predatory mites onto an almond tree that is 5 feet tall, 5 meters tall. So we need drones for that. So with this, we're now suddenly demonstrating to the almond growers that they can also rely on this. So we are opening up for new crops to use this technology, and we are developing. With this will be completely new careers. There's going to be drone pilots. There's going to be programmers. There's going to be also engineers, all sorts of people that are needed for this to be commercialable, for something that can be put into action. And we are promoting all of that as much as we can. So to conclude, I want to present sort of a brief worldview, that the words are sort of to sort of bring everything together. I really think that we need to remember that waste equals unsustainability. That we need to, all of us collectively, think about how we can abolish this word. I just saw on TV today that Adidas is starting to make shoes out of plastic bottles, right? And I know other shoe companies are doing that. Well, of course. I mean, of course. We can make roads with them. We can do all sorts of things. All this plastic waste shouldn't be thrown in the ocean and kill our marine life and all this sort of stuff. It's a resource. It has value. So waste equals unsustainability. And I think as these global changes are sort of encroaching on us and causing more and more threats to humans and wildlife and others, we need to look at them as demand for change, and they really force us to come up with opportunity, with new solutions. And there are very, very low hanging fruit that could be picked up. Very, very important opportunities for us to engage in that. And we can do that by rethinking our education through empowerment of students. You as students need to demand more hands-on experimentation. You need to ask for more hands-on experience. And what you are learning in the classroom needs to be converted into something that has meaning to you, to your community, and is in action right there in front of you at the school or university where you are. Because I really think we need to get these local communities involved, engaged, and we need the companies that hire you. We need them also to pour money into the universities so that they have the resources to do this kind of work. But I think they will, because they have a lot of reasons to do this. And that ultimately, if we do these things, will lead to disruptive ideas and solutions, and it will allow us all to dare dreaming bigger and ask what if more often. And that is really what this lecture was all about. So, Professor Jenita, I'm so thankful for this opportunity. If you want to, again, read more about what we're doing, this is my website. I've talked about technology-driven frontiers in entomology. You can see there's some similarities, but there are some other technologies that I didn't get a chance to talk about today. You can find these YouTube links on my website. And with that, I will take questions, and thank you so much for your attention.